Hello everyone, thank you very much for coming to the LabVIEW user group. Yes, so I'm John Medland. I work for Control Software Solutions, who not host the event, but I'm doing a talk here on some open source computer vision stuff. Yeah, I'll just dive right in. So just some basics in LabVIEW, like thinking about computer vision, about our base data type, our image, which is what's going to store our data, what we're going to process. And maybe we'll also output some images at the other side. So there's like two image types native to LabVIEW, I would argue. The first is PixMap, which is it looks like this control type object, and it's got like metadata about the image and image data and masks and other stuff. Like, it's just great. You might use in PixMap if you are using the load and save native LabVIEW VIs for like saving JPEGs, PNGs, and bitmaps. It supports if you have a PixMap image, you can specify that one of the colors in that image should be a mask, and then when it comes to like displaying it, it will not display those pixel colors; they just get masked out. If you use something like a LabVIEW VI methods, like get an image of a controller, get an image of a graph, return a PixMap. So there you go. Yeah, so you might use that specifically for like loading and saving stuff. The other LabVIEW image type is the picture. So the LabVIEW picture you typically associate with actually like rendering, drawing something on the screen. So you get this picture indicator, and then as well as like taking a PixMap and writing it to a picture to display it. The picture is also a way of like drawing primitive shapes. So you can layer up, you can concatenate pictures, like using the concatenate string, which I absolutely hate that that's a usage for concatenate string, but you can concatenate pictures, or you can just draw over the top of pictures. So you can like add primitive shapes, circles, squares, arbitrary points on top of a picture. And when you come to display it, that thing will be drawn on top. You can, if you have a picture indicator, there is a property node called image zoom. So you can actually, in a way, mock like or mimic sort of scaling the image in some way without having to think about like actual scaling. Like, you're just going to do that graphically on the UI, which can be really handy. And yeah, there's LabVIEW provided functions that you convert between PixMap and pictures back and forth. Yeah, so if you're working with computer vision, like, it's useful just to have this foundation in how LabVIEW might represent pictures. There is, of course, the other image type in LabVIEW. So the one associated with the vision acquisition module, vision deployment development module, that is IMAC. Yeah, you get this like IMAC image display, which like has these useful tools and stuff on it. This one, compared to the others, this one is by reference. So if you have this purple like wire, that's just a reference to the image. So that we can pass that around without passing around the data. The other two types, like the actual image data, is encoded in the wire. So if you bundle it or put it in a queue, it'll be like duplicating that data. So those are just things to bear in mind. If you're going to be using LabVIEW in a range of vision acquisition situations, you might be using the off-the-shelf NI vision tools. They have like licenses associated with them. But there is actually a very small subset of IMAC that doesn't require activation. So technically, it's only the vision development module and vision acquisition that are specifically licensed. There's a flowchart online. You're like, am I doing this? Okay, you need this license. Am I doing this? Okay, you need this license. But you can get a really tiny subset of IMAC without additional licensing costs, which is nice. Cool. So we've got those two built-in types, and then this other type that's often associated with machine vision. Cool. Any questions? No. So you're talking open source. So quickly, I'm not going to read all of this. When I'm talking about open source, I'm talking about stuff that is free to distribute. You can read, modify, distribute source code. You can create derived works. There's various things around. Like it's free for everyone. Like you're not excluding people certainly from using it. There's a license associated with its distribution. There's a full list. If you're curious, like go to the open source initiative. But like what they count as open source, count as open source. So yeah. So if you're looking at doing machine vision with LabVIEW and you don't want to go for something like vision development module, you might consider using Python. So we now have the Python node in LabVIEW, which would mean that you can offload to some image processing library in Python, like OpenCV. I'm going to mention that a lot, but that will be one classic instance. So if you're interested in seeing that, James McNally did you can hide if you're hiding my information. James McNally did a talk, I think at LabVIEW 2022 LabVIEW Connect, and put his example code on his GitHub, which is there. We'll share the slides with all the attendees, so you can check that out. I mean, that's fine. Like, sure, Python's great, but we like LabVIEW. Just to be fair to other text-based languages, so we have the Python node in LabVIEW. We also have C# .NET integration. So Weaver has this great, an interesting talk on stuff he was doing using C# to bring in OpenCV into LabVIEW, which might be quite interesting to see what he did. So yeah, that's another link to the video. Well, that's the link to LabVIEW wiki that has the video and other information. So if you're interested in using .NET, then that's a good place to look. If you just want some something that's a bit more than the LabVIEW built-in functions, but just image file manipulation or resizing, combining images, composing, then there's this one on VIPM from Uber, lots of those. Yeah, so that uses .NET under the hood, which I guess it means it only works on Windows. Not I don't think I have quite got the Linux.NET working. I imagine it's on some roadmap, but we'll get there eventually. Yeah, so if you're only targeting Windows systems, you just need some simple image handling. If you reach for this toolkit, it's open source. If you want to take the route I did, which was C++, then luckily I've done all that boring C++ work for you. You might find C++1. Good for you. I did enjoy it. Anyway. So I created this open source toolkit. When I originally started it, it's just a sort of hobby project a couple of years ago, about 4 years ago. I was just looking to provide some native webcam capturing utility to LabVIEW, especially for LabVIEW community. And then B, I have been working on a research project at the University of Manchester, was using augmented reality to assist in understanding operators moving in a space. So originally I just intended that it would bring some augmented reality into LabVIEW as well based, because it's a hobby project and so it's fun to follow rabbit holes and explore. It now actually does way more stuff. So in total, there's about 9,000 lines of C++ behind the scenes, which is compiled to binaries. We call those binaries from LabVIEW. Lots of that code is making sure that the C++ code integrates into LabVIEW really nicely. So we're able to do things like use external data value references as a way of storing images. That means we can have efficient energy transfer. We can manage the lifetime of the data. So even if we forget to clean something up in LabVIEW, it gets cleaned up automatically when it goes out of scope. We can also always access just the pixel data. I'll share that in a second. Yeah, so it has that. It has a webcam driver, so that's the USB webcams. Also other stuff that presents a USB webcam, like HDMI capture cards, other stuff. Should appear on Windows. It uses Windows Media Framework, which is the modern Windows camera interface. It means it should do hardware transcoding if it can, other stuff like that. But yeah, whatever your operating system can do, it can sort of use those functionalities. On Linux, so I support Linux, both desktop and 64-bit RT systems. You use video for Linux, so you get the same, like whatever video is supported on Linux system, you should be able to see and operate with. I had originally intended just to do this bit of feature detection, the people tag AR markers, but because I'm using CD under the hood, it's actually pretty straightforward for me to bring in like lots of other feature detection, puff circles, contours, like other QR code types, barcode readers. Also got some text and OCR examples. Because you're doing lots of, like, when you're working with augmented reality, you often need to do other image processing. So we've got scaling, cropping, composing, color channel operations on images. And then finally, the bit that's like the maths behind augmented reality. So just to take a little side. So augmented reality is like the Pokemon Go of the world. You've got the real world, you've got a camera that's looking at the real world. You're like inferring something about the world from your 2D image of it, and then you can be able to like insert and overlay 3D assets in that space. So you'll see an example in a bit. But yeah, that requires just a load of mathematics, which I was able to integrate into LabVIEW easily. So that's all there. The 3D rendering side just uses the native LabVIEW 3D controls. So that actually saves a lot of effort. I could just leverage those. Also, there's video file handling, so sort of leaning on FFmpeg underneath the hood. So like reading and writing different video formats and container formats, and yeah, Windows, Linux, and NI Linux RT. So let's jump across to a demo. So yeah, for this demo, let's just run that. So got my webcam here, and then I've got like a little one. Got a little AR marker down here. It's just running on the screen because we get the printer to work. So the idea here is these QR code type things. I'll just pick it up. See if that works. It just kind of look like that. So yeah, like you know, it's like a QR code, but very simplified. Yeah, the idea is that I'm detecting it in the image because I know the size of it, and also I've got a rough approximation for the optics of the camera. I'm able to detect it and then draw 3D objects. In this case, this is like a really simple idea of projecting some points. So I understand, like from the camera and some mathematics, I can get like a 3D representation of the world. I can then decide and compute where a 3D point in that world would then appear on the image and draw on the image. That's a bit boring. I've also got an option where we are leveraging the, get this focused, the LabVIEW 3D control. So that's like the classic LabVIEW like XYZ axis marking. That's also a bit boring. So you can like load in models and stuff. Focus. I should set this to I do have camera control, so I could actually turn the autofocus off, but just start again. The camera a chance to have a think about what it's done. Okay, well, we'll come back to that. Yeah, so like I can load in 3D models. Come on. There we go. Like,
oh, there you go.
You know, you can put your 3D models into space, so you can render those. I've got a simple like OBJ format loader, and also it loads like textures and stuff. So yeah. Anyway, it doesn't just only track. It's distracting. It can track like many tens, hundreds of markers depending on the type of marker you choose. There's some families of markers that have tens of thousands, so you can sort of create a unique one for every thing you want to track in 2D space, in 3D space. Sorry. Yeah, so you know that's augmented reality. Some of the other stuff the library can do. So yeah, so these are like just some plotted examples from the library that you get when you install it. So this is the augmented reality stuff that we were doing. Just go over some of it. So here we are enumerating our cameras, and just like in this case, I've like hard coded the camera I want to choose in its format. Then I need to get some information about the image just to like fake some like what we call the camera calibration matrix. So that's like guessing what the optical parameters will be, so that the illusion sort of works. But in theory, you can actually measure that and compute that properly using some of the other tools in the toolkit. And then, yeah, once the camera's started running, it's just going to grab the frame, and then here we're assuming that was valid. We would have that's the call to get our detections, and then we're just actually this is us then drawing those detections, and then doing like 3D rendering side, grabbing the image out, and then I'm just actually updating that on a LabVIEW picture. So none of this uses any IMAX stuff. Like it's all yeah, doesn't require any other NI toolkits. You install it and you're good to go. Got like time. So there's way more stuff. Right. So yeah, you just like there's lots. Yeah, all sorts. There's some fun examples. Maybe if you're interested in how the augmented reality stuff works in the background, let's just try this one, and then this is just going to run from like static images from disk. So you have some known object, you're able to infer like information about it and understand where it would be in 3D space. You have your 3D scene that you manipulate based on like your understanding of the camera's perspective. You can also then like warp it. So I've got like a slightly weird camera optic. So there I'm actually warping the model to match the camera optic, then I'm masking it, and then I'm overlaying it. So like that's the talk through the process of how it all works. Other fun stuff. Yeah, so like there's a load of other detection objects, but like image detection using YOLO is all the range. So like YOLO detection, so it's found a dog and sports ball in that image. So I'll go back because there's other stuff I wanted to cover, but there's lots, and like I say, it's open source, it's free, it's on VIPM, download it, have a play. This. Current slide. So that was looking at like webcam stuff, but for like industrial applications, you're often not using webcam, using like a Basler cam or IDS or something. Most of those cameras that you encounter nowadays will use the Gen I cam standard. And so the other thing I've written in C++ and brought and integrated to LabVIEW is this toolkit. So it builds on an open source project called Aravis, which does like all the hard work. I then just like wrote the wrapper code to make it work nicely in LabVIEW. So do really quickly run a demo on that. We'll see if that one works. Like there's a lot going on my computer now, so I've got like a webcam and the Basler cam, but just get that one. Cool. So yeah, also on VIPM, just an example. Let's see if we can just do the streaming. So this one also works on Windows, Linux, and NI Linux RT for 64-bit targets. Yeah, it's happy. 1 second. I've got some quite ropey USB ports going on this old machine. Cool. Yeah, this one isn't going to play, but yeah. So like, it works with. I mean, it works with USB 3 and like Gen Gig E cameras. Yeah, so the idea there is that you can speak to like and control industrial cameras, like yeah, configure them, adjust the triggering, all that stuff. One last try. Not going to play. No worries.
What's the main difference between digital camera and camera?
It's primarily the protocols they use. So yeah, and also like webcams maybe sort of top out at like 60 frames per second, whereas industrial cameras can go to like many tens. Also, they're just like generally easier to deploy and manage, so you can speak to that from like it's a bit easier to interface with that than like a webcam because you're not using the USB stack all the time. So yeah, also you get more choice over the optics, so you can like bolt on any appropriate optic there to get the yeah. But yeah, that does work. This one is just in beta because I don't have a huge suite of industrial cameras to test with. But if people do have industrial cameras they want to play with and see if they work, let me know how they get on. Just open an issue on the repository for it, which is linked from the LabVIEW page. Cool, yeah, so like those two libraries that I've shown, they're not really meant to be replacements for the NI vision deployment, vision development module, just like an open source alternative if the use case fits. Also, like for my augmented reality library, I'm just assuming that you're dealing with like RGB or grayscale images. I'm not doing like I16s, like floating point images and stuff. So, like it won't be appropriate for every situation, but like give it a go. 3, why not? Yeah, so that's what I'm wrapping around this library. Oh, I should say, so both of my libraries, the binary parts are LGPL 2.1, so you can integrate them into commercial applications without having viral effects of licenses. I specifically built it so that the LabVIEW wrapper is BSD 0, so that's easy to integrate, and then you can swap out the LGPL version, therefore it's compatible with the LGPL license. Anyway, yeah, so you can use these for hobby, commercial, whatever projects. You just have to make sure that if you do it as a like project that you're selling, just make sure that you let people know what software you're using to comply with the license. I did a big talk on it at GDevCon. That was the demo that didn't work. And then, so just some other things. So it doesn't just seem like selfless promotion for my toolkits. So there's another project on LabVIEW. It's also a work in progress from author called Lucas. And he is using the fact that you can use some of iMac as like the basic iMac stuff without any additional licensing requirement, any additional license needs. And then sort of building stuff on top and looking at explicitly bringing in OpenCV to LabVIEW, so you get like feature parity between the APIs, whereas I am more just using OpenCV under the hood and then making that maybe exposed to you, maybe not exposed. So it's a different approach that could help bring like open source image computer vision stuff into LabVIEW. Yeah, so that's good. I would take a look. The OpenCV part that's especially interesting to me is currently in preview, so it isn't on BRPM, but you just follow through the links. Also, he's got nice docs. My docs, we're getting there. We're getting there. Other lovely open source libraries, just sort of flag. So if you need to do a bit of saving, loading images, GIFs, SVGs, quite nice. There's another package called Gimage, which does that in LabVIEW and is like C++ based, so will also work on Windows, Linux, and also Mac on this one. So yeah, there's other cool stuff if you have any image needs. Yeah, thank you.